Welcome to the world of artificial intelligence. As we discussed in the last episode, one of the most interesting components of artificial intelligence is the rational agent which knows how things work in the world and makes decisions according to the world. But what does the world look like from the perspective of a machine? Think about the vastly different worlds that a self-driving car agent and a chess-playing agent exist in. We call the agent's perception of the world environment, and in this episode, we're about to take you on a journey to explore the different types of environments in which agents can operate. As rational agents navigate the world, they encounter a wide variety of environments, each with its own unique characteristics. Understanding these different environments is crucial for understanding the behavior and decision-making processes of artificial intelligence. Our world is defined by 8 parameters for the machine. Let's check them out. The first parameter is the level of observability in the environment. Fully observable environments are those in which an agent is fully aware of both the environment's current condition and any changes to it. This implies that there are no hidden or unobservable details in the environment and that the agent can perceive and understand all pieces of it. A chess game is an example of a fully observable environment since the agent can always see the entire board and all of the pieces at all times. On the other hand, partially observable environments are those in which an agent does not have a complete understanding of the conditions of the environment, and there is hidden or unobservable information. A self-driving car, which can only sense a small portion of its environment, such as what is visible through its cameras, is an example of a partially observable environment. Next, it is the determinism of the environment. An environment that is deterministic is one in which the system's rules, initial conditions, and outcome are all fixed and predictable. This means that the agent can predict the outcome of its actions with certainty. The chess game is an example of a deterministic environment because the rules of the game and the movement of the pieces are fixed and we do not add a new piece to the game while we are playing. On the other hand, a stochastic environment is one in which the outcomes are uncertain due to the randomness of the environment or the actions of other agents. The self-driving car is in this category as the car may need to make sudden stops because of unexpected events. The next parameter is related to whether the agent is alone or not. A single-agent environment is one in which the agent is the only decision-maker. An example of a single-agent environment is a chess game, where the agent controls all the pieces. On the other hand, a multi-agent environment is one in which there are multiple agents operating in the environment. A self-driving car is a good example of a multi-agent environment. The agent communicates with other self-driving car agents and traffic control systems, and the decision of one agent depends on the decision of other agents. For the multi-agent environment, we have competitive and collaborative environments. A competitive environment is a situation where multiple agents are competing against each other to achieve a common goal. Agents must make strategic decisions to achieve the goal while maximizing their own performance. For example, in the League of Legends multiplayer game, an agent can be a player who controls the character, and the ultimate goal of the game is to defeat the opposing team and win the match by destroying the enemy's base. On the other hand, a collaborative environment is one in which the agents are working together towards a common goal. For example, a group of friends working together to solve a puzzle. The agents in this scenario are the friends, and the environment includes the puzzle and the rules. The friends must collaborate to make decisions and take actions that will lead to the successful completion of the puzzle. The next parameter is the stability of the environment. A static environment is one in which the state of the environment does not change over time like the chess game, where the rules of the game and the positions of the pieces do not change during the game. On the other hand, a dynamic environment is one in which the state of the environment changes over time like the self-driving car, which must continuously navigate a changing road network and respond to the actions of other drivers and people. The next parameter is related to whether the agent's decisions are connected to each other or not. In the chess game, each move the agent makes affects the game state and the potential future moves, which are sequential environments. On the other hand, when each decision is independent of other decisions, the environment is episodic. Finally, the last parameter is about the amount of information available to the agent. In a known environment, the agent has complete information about the task and the environment. In contrast, in an unknown environment, the agent may have limited or no information about the task or environment. For example, a self-driving car operates in a known environment, as it has access to a wealth of information about the road, traffic, and weather conditions. However, an agent exploring an unknown planet would operate in an unknown environment, as it would have limited information about the planet's terrain, resources, and potential hazards. Eventually, when we want to define our world for artificial intelligence, we must determine these 8 parameters so that it can understand our world and make decisions in it. So far, you have learned a lot of new information about what artificial intelligence is and how it works, but wait. There is still a lot of information about AI that can change your life in the 21st century. Don't forget to like, subscribe, and share your thoughts. We'll be posting regular updates and insights to help you stay ahead of the curve in the world of artificial intelligence.